Welcome to the lesson on parallel and perpendicular lines. In this lesson, we will discuss the basics of these two types of lines and how they can relate to greater ideas in geometry. Now, parallel lines are lines that never intersect. Perpendicular lines do intersect, and they do so to make a right angle. With these two types of lines, it's important to think about the law of the excluded middle. Essentially, with two contradictory positions, one must be true and the other must be false. There is no middle ground or third possibility. For example, lines are either parallel or they're not, but perpendicular lines can be perpendicular, but they can also intersect in many other ways. Let me draw a few examples. I can have two lines that are perpendicular, but I can have two lines that are not, and they can intersect with lots of different angles. Lines, on the other hand, or parallel lines, are either parallel or they're not, or they intersect. Now, some basic theories do exist with these lines. So here I have two parallel lines, and I'll denote them with the two arrows for these parallel lines. And I have another line, line AB, over on the left that is perpendicular to both of them. So if a line is perpendicular to another line, then it must also be perpendicular to a third line that is parallel to it. Essentially, because AB is perpendicular to CE, it must also be perpendicular to DF. None of the angles change. Since two lines are parallel, that line must be perpendicular to both. Also, if a line is parallel to another line, then it must also be parallel to a third line that's parallel to it. If I make a line that's parallel to CE or DF, they're all going to be parallel. If I make a line parallel to one, it's parallel to both. Now, the last one, through one given point, there exists only one possible parallel perpendicular line. I can make a point, and that point's only going to yield one possible parallel line and one possible perpendicular line. And any of those results are going to be perpendicular to both and parallel to all those lines that you see. Now, these laws do have some exceptions. Theorems and postulates we've been talking about and we discussed refer to figures and lines on a two-dimensional plane. Now we know that in our three-dimensional world, there's different rules about how lines can be parallel. Some of the examples exist particularly with circles, or in a three-dimensional world, with spheres. With elliptical and hyperbolic geometry, we get ideas that 2 points are essentially connected by curved lines or on the outsides of these spheres that make greater half circles. So in a sense, with these ellipses and spheres, no lines can be parallel.